The graph of above consists of two straight line segments. Okay, now I see that. Let G equal this thing, f of t, for values between -3 and 5. Okay, so whenever you get graphs like, or problems like this, make sure you label what your graph is. Okay, we know that it's f. We're also the problem also defines another function g that uses f. And because you guys know the fundamental theorem of calculus, you know that if you were to take the derivative of this, like if you took the derivative of g, you would get just f of t, because the derivative of an integral cancels out the integral, and you take what's inside, you put it inside there, and you just get whatever inside the integrand. I need to put an x right there. Okay, all right. So if this is f, then that is also g prime. Okay, good to know. That really helps us think about the rest of the problem. Okay, the first one says find the values of x for which g has a local maximum. Justify your answer. Okay, so for letter A, we're looking at g prime right here, which is our graph, and we're trying to find out where g has a local maximum. Yes, we're going to look at g prime to find out where g has a local maximum. This is where we use a sign line graph. I always like to label my sign line graphs. So for this is g prime. It looks like we have g prime equaling 0 at 0 and at 4. See? Right here we have an intersection at 0 and an intersection at 4. That is where g prime equals 0. So here's my sign line graph, and it looks like before this this x value is 0, that g prime is negative. So I'm going to put a negative right here, and then we go above the x-axis right between 0 and 4. So I'm going to put a positive there, and then we go below the x-axis after 4. So I'm going to put a negative right there. Now because we are going what do we look for? Maximum or minimum? Maximum. Because we're going up then down for g, then we know that there's a maximum right there. So we could say at x equals 4, there exists a maximum. Sweet. Actually, not just any max, a local max. We actually don't know if that's where the maximum is until we start testing values. In fact, that's what this next problem is going to do. It's going to try to see if we know that we're supposed to test some values. So it says, what is the maximum value for g on the interval from -3 to 5? We got to justify our answer for this. When we justify our answer for this one, we're going to use our work. Okay, let's see. For the other one, we had to justify our answer. To do that, we did a sign line graph to show that there exists a local max. Okay, to justify our answer for this one, what we're going to do is we're going to plug in all of the x values where g prime equals 0, because where g prime equals 0, that's where you can have a maximum or minimum. For example, okay, right here and right here, g prime equals 0 because we have horizontal tangent lines. Okay, so those have the potential of being the maximum, but it's not always the maximum. Like we could have this and then boom, we stop right there because that's where our interval is. Let's say this is B and this right here is A. Our interval is from A to B. This is a local maximum which we can find using a sign line graph, but this guy is the maximum because he is obviously higher than this dude. Okay, so we have to test the endpoints. So in this case, in my fun little illustration here, I'd have to test A, I have to test B, I have to test this guy, and I have to test this guy. Now we wouldn't have to test for this dumb picture that I drew because I can see it. We wouldn't have to test anything. But for our problem right now, we don't know what G looks like. All we're given is this. We can graph G to find that out, but that's a lot of work and I don't want to do it. So what we're going to do is we're going to take G and we're going to plug in our critical values, which are 0 and 4. Remember, critical values are where g prime equals 0. And then we're also going to plug in the endpoints. So we're going to plug in -3, and then we're also going to plug in 4. Now, because one of my critical values is 0, and I know at 0 we're going down then up, I know that this one, a local minimum, can't possibly be a maximum. So I'm just going to nix that one right off the bat. But 4, I don't know. So that could be our maximum. Right now we know it's a local maximum, but we don't know if it's a maximum. So let's plug the 4 into this dude. So it would look like so. We go 2 to 4 of f of t. Is that t? Yeah, f of t. And because I know the graph of this, in order to find the answer to this integral, all I need to do is find the area underneath the curve, or between the curve and the x-axis. Okay, so if I'm starting at 2, and then am I starting at 2? Yeah, I'm starting at 2, and then I'm going to 4, then that means I'm looking for the area right here. Using geometry, I'm going to go 1/2 base times height. That'd be 1/2 the base, which is 2, and then times the height, which is 4 of my triangle. The 1/2 multiplies to the 2 to equal 1. So it looks like I get a positive 4. A positive 4 because we're going right to, or left to right from 2 to 4. Now we're above the x-axis. The integral is 4. All right, the value is 4 at 4. Okay, now let's try -3. When I do -3, I'm going from 2 to -3 of f of t. So what's the area underneath the curve? F. Let's see. We're going to go from 2 to all the way to -3. Okay, so this area right here that we have to find, that one would be a negative area. And the reason why that's a negative area is because we're going right to left. Okay, and then so I got to find the area that, and using geometry, that's going to be the same as the other one. So I'm going to put -4. Remember, we got 4 on the other half. Okay, then I'm going to add to that the area underneath this curve, or the area between the x-axis and this curve. And so this guy right here, whoops, yeah, okay. This guy right here has a base of 3 and a height of -6. Now this guy should be positive when we're done because we're going from right to left. And so when I go right to left on that guy, let's see, we go, well, it's 1/2, and then we're going to go base times 3 and times -6, but I know it's going to be a positive answer when we're done. 1/2 of -6 will be -3. -3 times 3 is going to be -9, but I know it's going to be positive. Maybe I should just like put absolute value bars right here so I make sure that I make it positive. So when I add those two together, -4 and 9, that equals 5. Oh snap, look at that value right there. 4 is less than 5, so it looks like our maximum, our true maximum, is not at 4, only our local max is at 4. Our true maximum is going to be at 5, or that's our maximum value. It's going to be located at -3. But let's still try, wait, 4 and 4. Oh no, 4 is not my endpoint. Oh man, I said it was the endpoint at the beginning, but I'm not going to redo this video. Let's see, G of 5. Okay, so G of 5 is right there. It's a little after the 4, and I already know that this is not going to be a maximum value because from here, from 2 to 4, I got 4. Then if I go a little more to 5, I'm going to be adding negative area. I'm going to go ahead and find it just so I can write it down. That would be 1/2 times 1 times -2. So that would be a -1. I would get a 3. So our maximum value is 5. Okay, now it does say value, so that's good. It kind of helps you remember. Whenever you see the word value, you must think Y value. Your answer will never be an X. Last but not least, our last question says, on what subintervals of -3 to 5 is the graph of G concave up? Okay, so the only way we know if G is concaving up or concaving down, or it's not the only way, but one way, is to know what G prime is. If G prime is greater than 0, then we're concaving up. If G double prime is less than 0, that means we're concaving down. Now, if G is concaving up, that means the slope is increasing. If G is concaving down, that means the slope is decreasing. Okay, just a conceptual fact there. Now, because we know that G equals F prime, I'm sorry, wrong way. Because we know that G prime equals F, that means if I look at the derivative, or the derivative of F prime, that equals G double prime. And this is very important to state. This is what justifies our answer here. Okay, so we're saying that G double prime equals F prime, and F prime is the slope of F. And so we just have to look at F right here. It's going up right here, and then it's going down right here. We just have to look at F prime to find out where G double prime is greater than or less than 0. So because F prime is greater than 0 when x is between -3 and 2, G double prime is greater than 0 between -3 and 2. So this is where we're concaving up. Therefore, concave up between -3 and 2.